Hello, Carly Solali here. In this video, we're going to take a look at graphical user interfaces with PowerShell, or GUIs. Graphical user interfaces can make things much easier for your end users, for the people who use your scripts and your applications. If you can take your code and, give it a nice menu structure, or put it into something with a nice form and graphical interface, just makes it easier to use for the average user. Now, we have written menus in the shell. We've written menus that display at the command prompt, like old DOS menus, and they can be very useful too. But in this particular video, we'll explore GUIs. So the first thing we want to look at is a basic Windows form, okay? And I tried to just use comment tags and show the basic parts of creating a form. So first we have to add the required C#.NET namespace and classes, and that's with add type assembly name system windows.forms and system windows forms application enable visual styles, okay? So anytime you're going to make use of a graphical Windows form component, you want to add that to your script. The next thing we have to do is instantiate a form object. And remember in the video on classes, we talked about how a class is a blueprint, and when you build an object from that class, you're making an instance of it. You're instantiating it or constructing an object. So that's what you have to do when you're going to use a Windows form. You have to build or construct that class of objects. So we're using new object, just like we would with the class we wrote ourselves, and we're constructing a system.windows.forms.form object. And form main is the variable that sort of points to. In C++, we'd call it a pointer, but it points to that object in memory that we instantiated, okay? Number 3, set the size of the form, right? And this is just how big it is, 350 by 350, width by height. Same thing, notice that we're creating a system drawing point with new object, right? And it uses the dot operator, and it's on the pointer, or the variable that we use to point to our Windows forms object. So it's all, form main, you could call that whatever you want. Supercalifragilistic, banana, whatever. But the point is, that's how we're setting the size, the dot operator. And then to affect the form all the way down, it's the same syntax. We just use the dot operator, right? So we included what we needed to as far as the required classes and namespace. We built or instantiated the form object. We set its size. Now we're going to set the position of the form. And there's several ways to do that. You can use the value center screen. If I pass that in here in double quotes, and that would just have it appear in the middle of the screen. Or you can set it by XY coordinates if you want to. But if you do that, you want to set the start position to manual and then set the location, okay? And I'll put all the source code. I'm going to go through these fairly quickly. But remember, you can always pause the video and read over the code, or you can rewind it if you need to. So I don't think I have to spend a whole lot of time on each subject. I think I can go through them quickly, and you can pause where you need to. Also, I will put the source code in comment tags that I pin under each video, or in the description tag. Depends on where I can fit it. So you can always copy and paste the source code into ICE or into the development environment of your choice, and kind of play with the code and see what it does. So we can kind of skip through these fairly rapidly, and then you can pause, just sort of do a broad overview, and you can pause the video when you need to, okay? So that's setting the position of the form, X and Y coordinates. I can set the text, the top window of the form, okay? In this case, Carly, this sparkly unicorn, or whatever you want to set it to, typically the name of your application. I can set the form's background color. And to do that, do you remember this? Remember when a method is static? In that video we did on classes, we were talking about how you access static member data from a class, so you don't have to build an instance of it first. Well, notice that's what we're doing here. Right up here we had to use new object, and we instantiated or built instances of that. I think we covered some pretty good stuff in that classes video, because you see it all over PowerShell. It gives you when you understand how classes work and when you understand how they function, then you see it everywhere in PowerShell and in .NET and in C# and you see that everywhere, that class type structure, that design philosophy. So here we're not doing that. We're not using a new object. We're not instantiating. We're not building an object. Here we're using static member data. And so that, it's just acting as a means of organizing the code there. But we want to set the system color, which is just a hex color. You can Google any color you want for hex values. And I'll also show you, so at the end of the video, I'll show you some GUI tools that can help too. But right now, we just kind of want to focus on the code, okay? And there's two ways to display the form, but when you build a form, the last step, all right, in this case, step 7, the last thing you're going to do is always going to be called ShowDialog on that form. That causes that form to launch and display. And there's two ways to call ShowDialog. You can call it with feedback, which while you're running the form, it'll give you some feedback in the console, or you can call it and pipe it to Out-Null, in which case it'll give you no feedback. We'll look at both ways. So let's go ahead and launch this. All right, and so see, it creates this form here, curly the sparkly unicorn. The background is black because we made it black, and the size is, in this case, or the location, it appeared 800 by 300. It's about the middle of the screen, and the size is 350 by 350. Okay, so 350 wide by 350 tall, and that's ShowDialog. Let me, all right, and let's just run it one more time. All right, so see this is the initial location under which it appears, okay? And see the cancel here? Can you see this cancel? All right, so that's because I clicked on the X to close it. That's sort of some feedback. But if I comment this out, and this time I do ShowDialog and I pipe it to Out-Null, okay, so now when I close it, see, now there's no output, there's no cancel there. So this can be useful when you don't want debugging information written to the console when you're running a Windows form object. It's up to you, but I like to give you guys options. So these are all the basic parts of a very simple Windows form. Okay, so we've gone over creating a simple Windows form. And before we get into the components, the .NET and the C# components we can utilize with PowerShell, let's stay focused on just the form for now. You can actually draw things, vector graphics and text, right on the background of a Windows form itself, without even adding a text box or a label or buttons or things like that. So before we get into all those components, while we're still talking about building a simple, just a form, let's look at actually drawing on the background of the form itself with different functions, different things, okay? Now there's two basic things you need to do if you're going to draw on a form. First, you need to call the CreateGraphics function on the form object itself, okay? So basically you have a variable that would be set up as a pointer, and you would use the name of the form, whatever you choose to call it, and you would call the CreateGraphics method on the name of that form. And so then this points to that. It sort of gives you a pointer to the background of the form, and so it lets you use the background of the form as a canvas to paint on, using, in this case, whatever you call this in the dot operator. So you have to do that, and that will become clearer in a minute. And the second thing you have to do, when you program with GUIs, with the graphical user interface, you have to get into what's called event-based programming. And you add all these components, you have a visual form. Well, it's not like programming for the console. When you program for the console, you control what the end user can do. You can keep them in a holding pattern, with your ASCII menu, your awesome ASCII DOS menus and things. You can kind of control the program flow and where they go and what they do. Kind of like the outer limits. We control the horizontal, we control the vertical. Well, in console programming, you can do that. You can't do that with a graphical user interface. With a GUI, the user's in total control. And so what happens is you add these components and they have to listen for events. So they sit there and they listen. And an event is a trigger. It's a certain type of behavior. The user clicks a button. The user moves the mouse. The user presses a key. Some event happens. And when that event happens, it acts as a trigger, and it triggers that event handler, and that event handler processes the code. Well, the event handler that you have to override, remember we talked about overriding versus overloading in the classes video? If you haven't watched that one, I recommend you go back and watch that because it will give you such a good understanding of how PowerShell works, and it will give you such a good understanding of how this works, of how creating GUIs with PowerShell works. If you understand how classes work, it's like you will see the structure behind all the code, and you'll see how it fits together, okay? So anyway, back to our current topic, GUIs. We need to override the built-in add paint method. Add paint method is called automatically when you display a form. It paints that form, right, on the user's display. And so they see that, they see the graphical, the user interface, the GUI. Well, that's the add paint method, and there's a built-in default one. But if you're going to paint on the background of, I almost said an applet, this is not Java. If you're going to paint on the background of a Windows form, you need to override that built-in add paint method, okay? And then you would put code in there that you want to happen to display whatever it is that you're trying to display on the Windows form background. Does that make sense? If not, it will make sense in a moment when we actually start to work with it, okay? So I tried to number these sequentially as I did before. First thing we want to do, right? We need to add the required C# .NET namespace and classes. So add type, assembly name, system.windows.forms. And then here, statically we're calling enable visual styles from system Windows Forms application. Remember, always access static data. Okay? So, first step. Second step, we need to instantiate a form object. We have to build a form from the form class, the form blueprint, right? So we're going to use, as always, the keyword new object and system.windows.forms.form. We're going to set the size 350 wide by 365 tall. The position we're going to set to manual and manually position it at X 800, Y 300. The text we're going to call Kirkley the Sparkly. Yeah, how about that? Kirkley instead of Kirkley. Kirkley the Sparkly Unicorn. There we go. And we're going to set the background color. And it was sort of a, fuchsia-y, purpley, sort of cyan-y type, whatever. And this is just a HTML, hexadecimal color there. Okay, now this is important. The next thing we need to do, we need to get a pointer to the form background so we can actually draw some graphics on it. Okay? So if you're not going to use a component, if you're going to draw on the background of the form itself, you have to call the CreateGraphics function or method on the form. Well, this is just the name of the form that we built up here, right? That we instantiated. So form.createGraphics. And I need another variable to act as a pointer to the graphics context. So this is sort of like a paintbrush. If you think about it in code or in memory, we're sort of setting up a paintbrush in memory. So now this points to the background of the forms, and I call CreateGraphics, so it puts it in context that I can use all these functions, these built-in functions now, to draw vector graphics onto it or to draw string data onto it. Okay, so I do that, and then I assign it to graph. So I'll use graph and the dot operator when I need to use those functions and those methods to actually draw things. Okay, so very important for drawing on the background of a form is step 3. Also very important is step 4. Now, remember I have to override the add_paint method. So there's a built-in method called add_paint for every Windows form. But remember overriding versus overloading when we talked about that in the classes video. You must watch the classes video. Okay, so I think it was video 17, I don't remember. But okay, so we're overriding that. Remember when you override a function, you're creating a function with the same name that does as a built-in function or method, but it does something different, and you're putting your own code there. So that's what we're doing. We're overriding the default add paint, which just paints a basic form but doesn't do any kind of vector graphics on it or put strings on it. Well, we're overriding it with our own paint method because we're going to do some weird, funky stuff that isn't normally done to a form. So you do that a lot. You have to override a particular event handler to cause events or to handle triggers for those events that happen with your code, with things that you want to happen. Okay, so we do that. And remember, overloading is when you create more than one function with the same name, but they take different parameters or arguments. And also remember, you can override and overload at the same time. You can have functions that are both overriding and overloading. And if that's confusing, go back and watch the videos on functions and classes. And it will explain those topics. We talk about those topics. Okay, so first thing we're going to do, I created some functions down here, and these are just to try out and use some built-in graphics functions. You get, once you do this, right, when you call CreateGraphics and you override your own, the add paint method, you get access to all these really cool built-in functions. So you don't have to reinvent the wheel. You can use the stuff that's already out there that's been invented. So in the first example, we're going to call draw filled rectangles. And I should have put these in order and I didn't, but all right, so here's draw filled rectangles. So to do that, the first thing I have to do is instantiate or build what's called a brush object or SolidBrush. So here's new object, right? And I'm building a SolidBrush object. It's just a built-in object in the Windows.Forms class, and there's graphics objects that we get access to with CreateGraphics. And a underscore brush is sort of a pointer, right? A variable that points to, and the color is black. So it's a paintbrush. I can paint with it now. And I'm going to call this function 2 times, FillRectangle. And it just takes x coordinate, y coordinate, width, and height. Those are the 4 arguments, okay? Again, down here I call it a second time, x coordinate, y coordinate, width, and height. Okay? So if I run this form, now that add paint is overriding the default add paint, it's just going to draw some rectangles on the back of the form using this function here, right? In this case, our draw filled rectangles. So this is how that looks like. All right, so here's the form, Karkly the sparkly unicorn, and here's our rectangles. There's our filled rectangles. Okay, and I meant to close that, not minimize that. Does that make sense? Okay, let's take a look at the next function. And again, I'm going through this fairly fast, but if you need to, you can pause the video, right? And I will include the source code and comment tags under the video or in the description tag, wherever I can fit it. So you can copy it and paste it into ICE or development environment of your choice. You can play with the code and you can pause the video. So that way, hopefully I can do all this in less than an hour. I'm going to try to cram all these forms, components, and things into a video that we'll see. We'll see, See if I can do that. I have to turn off my verbosity mode and try to be brief in general. All right, so the next function, that was filled rectangles. Here we're doing the same thing, but instead of creating a solid brush object like we did up here, we're creating a pen object in this method. All right, so we instantiate, we build a pen object, same thing, same color, black, right? We can set the width of our pen object, so we're going to give it a good size point. 10 is pretty big size point on the end of it. And then we're going to draw not a filled rectangle, but this time an empty rectangle. So instead of using fill rectangle as we did before, now we're using DrawRectangle to create an empty rectangle, but it uses the same arguments. In this case, instead of a brush, a pen. That's the pen we instantiated and built here. And then the X and the Y and the width and the height. Okay. So if we run the form, now you can see here's our empty rectangles. Okay. All right, let's go look at another one of these cool built-in methods and functions that we get. Now we're going to draw some lines, okay? So how do you draw lines? Now that we have CreateGraphics to get our graphics context, and now that we have overridden add paint, we can draw some lines. And to draw lines, I'm just going to use the DrawLine method or function. And we need a pen, right? So we're going to instantiate or build a pen. It's black. And just to show you, I could have passed in blue and created it blue. But if for some reason you want to change the color of a pen, you can after you build it. And that's just to show you. And remember, you can get any of those. Once you have an object built, look, if I hit at least an ICE, you get autocomplete, right? IntelliSense. So it'll show you all the functions, member methods, and data members that you can access for that function. So you'll notice there's color, right? So if you doubt or if you don't know, just use the dot operator and ICE will show you all of the built-in data members, all of the built-in methods that you get with that particular object, in this case a pen object. That was just to give you an example. Set the width to 10th again. We pass it in as the first argument to DrawLine, which just draws a line. Okay? And then the starting coordinate x and y and the ending coordinate x and y. Right? Those are the arguments. Starting coordinate x and y, ending coordinate x and y. So if you look at this, this is inverted, right? The two arguments to these draw lines. And it's just going to draw two crisscrossing lines. X marks the spot because we're pirates. We're total pirates, right? I love pirates. I kind of have a fetish for pirates. I have a thing. I'm obsessed with pirates. Sorry, but all right. So correctly the sparkly unicorn. Here's X marks the spot because we're pirates. Yar, yar. Okay. So that's draw lines. All right. Here's another function. You can draw a Bezier curve. All right. And to do that, you have to create what are called point objects. You have to instantiate point objects, which is just a point that's an XY coordinate, and it will sort of histogram curve, you know, from this XY point to this XY point to this XY point to this XY point. So those 4 points, I've built them, and I can pass them in, all right, as arguments, as parameters. And I can add more points, if so desired, to make a more complex Bezier curve. But in this case, we're just going to use these 4 points here just to show you how it works, right? And you guys, you know what a pen is by this time. You understand we're building a pen. So we call it DrawBezier. All right, let's take a look at that. So here's our Bezier curve, right? And it's just curving from the 4 arguments that we passed in the points, the x, y coordinates that we instantiated, that we built up here. Okay. Let's look at the next method. Let's look at draw ellipses, okay? Draw ellipses. And if I draw ellipses, I'm going to use filled ellipse, okay? And there's also a draw ellipse, which we could use to create an empty ellipse, but I'm going to use FillEllipse. In this case, I'm going to pass in a brush, and I'm just trying to show you 2 ways of doing this. You could create a drawing.rectangle object, all right, if you wanted to, with an X and a Y and a length and a width. That's one way to do it. Or you could just pass in the arguments numerically this way. That's another way to do it. Either way. But it uses a brush, a solid brush object instead of a pen. I'm making my color pink. I'm passing it into the constructor. So I could do that, or I could set the color attribute later if I wanted to on the brush, just like I did with a pen up above, okay? So if we run it, there. So it's just basically, you know, creating 2 circles, 2 pink circles on the background of my Windows form. And finally, let's take a look at DrawString. DrawString is a nice, cool function. So I build up a string here. I have a message. And just like with a text file, with these Windows form components, and with the background of the form itself, when you want to add a new line, you have to add both a carriage return and a line feed. So you're going to use the escape sequence, this escape sequence, whatever you call that, the little over the tilde, you know, and then the N there too. All right, so R and N. And the combination of those, it's actually just one line, but I don't know, it's sort of a tangent, but you might notice if you just do the escape sequence for a normal line, you'll notice that doesn't work with Windows forms. It doesn't work with text files either. So when you're writing to a text file and when you're trying to add a line to move on to the next line in a Windows form or in a text box or something, you have to use the combination of these 2, a carriage return and a line feed, for the escape sequence. So just sort of a tangent, but hopefully a useful tangent. Anyway, we have a string, right? So I have a string here. We want to display that string on the form background. So first we need to create a font object. So we instantiate, we build a font object. I'm going to make it Comic Sans MS. That's one of my favorite fonts. And this is the point size of the font. So 2 arguments, the font face and the point size. All right, so I build my font. Next, I have to build a brush, a solid brush object, so I can then take my font and draw with it. And I'm setting the color to black, so the ink will be black. So a font and a brush, I built them, I've instantiated them, Now I need to create a drawing, and this is a very special RectangleF. Not a rectangle, but a RectangleF object. You need that when you use the DrawString method. So I instantiate, I create a drawing.RectangleF. I said that in a weird way, so hopefully it'll be a mnemonic and help you remember. RectangleF, RectangleF object, okay? I think if I say it weird, it helps as a mnemonic to remember a bit. And then same thing, right? X and Y and width and height, okay? Now we have all the things that we need to call the DrawString method. And again, it's, this is the graphics object that we got up here, right? With CreateGraphics, we assigned it to graph. So here it is, graph dot. I call the DrawString method, and all the things that we built up here, all these objects, the string and the font and the solid brush and the RectangleF, they all need to get passed in as parameters to DrawString. So I pass in message, my string. I pass in font, my font, brush, my brush, and rectangle, which is my RectangleF object, okay? And so if I do that, right, so now I'm calling DrawString message. Let's see what happens with the form. All right, so Karkly the Sparkly Unicorn, a long, long time ago in a galaxy far, far away, it was a dark and stormy night. And once upon a time, there was a magical unicorn, and she was so totally sparkly. And all her reindeer pals, they did not want to play with her because she was way too sparkly for them. The end. How do you like my story? Okay, so hopefully that gives you an idea of not just how to create a form, but some things you can actually do with the form itself, even before you start adding things to it. All the other components that we'll talk about in the future. So now that we've looked at basic forms and how to draw and use the background of a form as a canvas, so to speak, with graphics methods, let's take a look at adding components to a form. And again, I've numerically sequenced this process to hopefully streamline it and sort of explain it or demystify it. Okay, so the very first thing we need to do, as with any forms application that uses forms as a GUI, we need to include the C#.NET namespace and classes. So to do that, step 1, add -type assembly name system.windows.forms. And then we're calling that static member data enable visual styles, okay? So step 1. Step 2, we have to instantiate the form object. So we have to build the form from the form class. So we do that with new object, and we set the size of the form with client size, and we set its position with X and Y coordinates here. I'm going to change that from Carly to Karkly. Karkly is sparkly unicorn, whatever. Set the text at the top. It would be our application name, right? It would go at the top of the form. Okay, so that's step 2. Step 3, we need to build the form components. We have the form. We built that. Good. Now we got to build the components that we're going to add to the form. So this time, in this example, the third one, instead of drawing directly onto the canvas or background of the form, we're going to add other classes of object to the form, other components, right? Things that we have to also instantiate and build with the new object, function. So we're going to add a text box, and everybody has their own system. But my system, when I do GUIs, I like to prefix the type of the data type of the object with like the first couple of characters. I'll make what that object is. So I use this for taking input in this example from the user, but it's a text box. So I prefix it with TB. I mean, you could call it whatever you want. You could call it banana if you're Gwen Stefani, but the point is that it should be something logical. So where you look at your code and you're like, oh, well, that's a text box. You know what I'm saying? Makes it easier to, when you have a GUI interface that's like, 2,000 lines of code and has all kinds of components on it, it's hard to debug that if everything is just called some default, text box 1, text box 2, text box 3. You're like, what the heck? What the what? On the other hand, and you don't even know that it's a text box sometimes because it just, sometimes by default they're called something that's totally undecipherable if you use some GUI design tool that just gives it a default name. So I recommend going through your code and neatening it up and give everything a special name that stands for what it is and what it does, what it's made from and its behavior. So in this case, I know by looking at this variable, even if I had thousands of lines of code in my interface, and I were to come back to this later, I know that this is for taking input from the user, and I know that it's a text box. Because in my system, I prefixed it with TB, okay? Same thing for here. This is a button. It's an enter button. So I know that because it's enter, and I know because it's prefixed with a B. That's how I titled it. That's how I named it. That's how I coded it. I look at this and I know that it's a label, right? Because it has an L in front of it. And I know that it's for the name. In this case, the name of my user. Now this is the part that doesn't change. So it's on my form and it just says name. Now I know this is another label, but it's different. This is the label where I actually output. When I get input from my user, this is where I'm actually going to change and output that data. And I know that because I postfixed output to the end of it. And I know that it's name, and I know that it's a label because I prefix it with an L. This is just my system. It's not right. It's not wrong. Your system could be better, could be worse. You'll make up your own. I'm just trying to show you that it will really help you in dealing with and managing your code if you rename everything to a logical and well-organized type structure. So prefix what the object is, that a label, a text box, a button. And then what does the object do on the form? And then later on, when it comes time to edit that code, or you have to track down issues or modify something, it's much easier to do that because you can quickly locate components in your code because they're named logically. And they do, I don't know why I went off on that tangent, but maybe that will hopefully be useful to you or helpful to you as you code your GUI interfaces for PowerShell. So let's take a look at these components now. Here we're instantiating and building a text box. Multi-line, by default, this attribute is set to false. All right, so you only have a single line text box. But if you want a big text box that can hold multiple lines of text, you want to set the multi-line option to true. And remember, if you can't remember, you can always hit the dot operator, and you're going to get all these data members and all these functions related to that object, at least in ICE. And also a lot of the GUI design tools out there, you'll see field options, properties, sheets, or pages in that GUI design tool itself. We're going to take a look at one called Posh GUI, which is totally free tool. It's an amazing, good free tool out there for designing, Windows form interfaces for PowerShell. But whatever you use, doesn't matter. You could just use Notepad if you wanted to. I don't know why, you'd kind of be torturing yourself, but you could use Notepad. If you understand how these things work, you could just code it out, build it, set the options on it, set the width and the height and the location. And I did have to do that manually. You can drag and drop these components on a form with the GUI design tool, but when you actually run the code, a lot of times it seems like the components shift out of place, or so you do have to go back in the code after even if you use a GUI tool to generate the code, you still have to go in and edit the code later. So it is wise. It is good to rename everything with a logical name that makes stuff easy to track down. Easy to debug, easy to modify, easy to maintain. So we create the text box, we set all those attributes, we set the font, we set the point size, we set the location, right? The X and Y coordinate. Same thing here, we create a button, right? We instantiate called beEnter. I set the text of the button, the width, the height. In this case, the location, right? The drawing point, the font, and the point size. I create a label, all right? System Windows Forms label with new object and its name. And auto size is true, so it'll size itself according to the text value that gets passed into it. Width and height. Now in this case, because auto size is true, that can change based on the text value of the label itself, okay? And then the location, X and Y coordinate, the font, and the point size. And I'm just making another label, and this is the label that I'm actually going to update with a value. So this label up here stays the same. But this label down here, this is what's actually going to change with output, okay, from the form itself. And again, here's the font face and the point size, Comic Sans MS. So remember what we've done so far. We've added the required components. We built and instantiated the form. We built and instantiated the form components right here. So that's steps 1 through 3. Now step 4. Now that we've built them, we have to add them to the form. So the form name, right? Here's the form we built up here. We called it form_main. So form main.controls.AddRange. And there's an add method where you can add one component at a time. But I use AddRange. It's just a convenient method where you can add a whole array of components to a form all at one time. And I have to do that, right? So TB input, my text box, B enter, my button, L name, my label, and L name output, my other label. I have to add those 4 components to the form, okay? Now, additionally, if I want to do something with any of these components, I have to add what's called an event handler. We talked about that in the last video, excuse me, the last topic. That might be in the same video, but we talked about overriding the add paint method. Well, here we have to code an event handler for the enter button. All right, B enter up here. Now, I don't have to have event handlers for my text box. I don't have to have event handlers for my labels because I'm not using them for input. They don't really interact with the user. I'm using them for display purposes, for output. Okay? The only thing that's really listening for something to happen or waiting for the player, for the user to click on it or do something is my button. So that's all I have to add an event handler to. An event handler is like think of it like adding a pair of ears to your object. It sits there and it listens for an event. It listens for a trigger. And when it hears that trigger, it'll execute the code that you point it to. Okay, so I could put code directly into my event handler if it's just something short or small. But more often than not, I will place a function call. I'll invoke a function, and there might be hundreds or even thousands of lines of code in that function, but I'll call that function from within the curly braces of my event handler. Okay? So for anything on my form that's going to listen for events or triggers, it's going to interact with the user, with the player, be it a button, be it a combo box, be it a list box, a scroll bar or whatever. If I want my program to react to that, to react to what the user does and what the user chooses on my form, I have to add an event handler for every single event. For every single trigger possibility, I have to add a separate event handler for that component and for that event. So if I had 20 buttons on my form, I'd have to add 20 event handlers. And that's just for the click method. There are other events, other triggers besides just clicking the mouse that I could listen for. And I could add that on each component. So not only would I have to add an event handler for every single button, so it'd be like 20 event handlers if I had 20 buttons, but each one of those buttons can have multiple event handlers to listen for different events, different triggers, a mouse click or whatever. Okay? But in this case, the only thing I have to worry about is the enter button. That's the only thing I have to add a listener to. And again, maybe it seems like a corny example, but think of adding an event handler as adding a pair of ears onto your component. Okay? You're giving it a pair of ears. And so now it can listen to the end user. It can listen to the person who's using your form, your program. And when it hears something, when that user does something, they move the mouse, they click on something, they scroll something, they change or modify something, then it can react to it. That acts as a trigger, which calls that event handler, and then that event handler can go and call the appropriate function in your code to do something. So I hope that makes sense. In this example, all we're doing is, we're just going to take the label here, our output label, and we're going to change it to whatever they typed in the text box with the assignment operator. So we're getting the text value of that text box, and we're just going to assign it to the label. Okay, very simple. But this is our first event handler, so let's keep it simple. We'll get more sophisticated later once we get used to using these basic Windows form components. Okay. And the last thing we need to do in absolutely any Windows Form Graphical User Interface GUI application, we need to call the ShowDialog method, okay? So whatever the form name is, we always call ShowDialog to show it, okay? And remember, we went over the Out-Null option if you don't want debugging information written to the console. So let's run this form and see what it does. All right, so here's our text box, here's our inner button, here's name, and then here's the label for the output. It's invisible, you can't see it, but it's there on the form, right? It's there on our code. And I'm gonna say Carly Salali. I'm gonna hit enter, and boom, that's all it does, right? So the event listener is listening on our button, right? And it takes what we've typed into the text box, and it shows it right here in this label right here. Now we're going to take a look at creating a form with GroupBoxes. GroupBoxes are a very useful way to add components to a Windows form. It gives you a lot more control over where you position them, because it can use relative positioning instead of absolute positioning. So you can create multiple group boxes and you can nest like radio buttons and normal buttons and text boxes and labels and things in that group box. And then you can move the group box around. And when you move the group box around, it moves all the stuff inside of it with it. Sort of relatively positioned to where you put that group box. Also, when you put radio buttons in the same group box, it's what gives the radio button its characteristic behavior, where you can only click one of them. And when you click one, the others are unselected whenever you select one. That's done by putting those radio buttons in the same group box. So let's see how we do that in code, and we'll just see how that looks, okay? So we have a form here, and we have two group boxes, group box top, group box bottom, okay? And notice when I select these radio buttons, if I select the top one, the bottom one deselects. If I select the bottom one, the top one deselects. The reason that behavior is occurring is because they're both added to the same group box top. And then this text box, this multi-line text box is added to that group box as well. And I could play with my X and Y coordinates. I could move this group box all around the Windows form. And if I do, the radio buttons and the text box go with it. So how cool is that? That can save you a lot of time, because you can spend a lot of time. Even if you use a GUI design tool, you could still spend hours and hours and hours after you've created your initial form going in and changing your code and cleaning up your code and making things that you can only do with code. There's a lot of things there's GUI form tools, they help at first, but there's a lot of things that they don't do. And ultimately, you still have to go in and you have to tweak all the code and change all the values in code. So group boxes are great. If I were doing a large, sophisticated graphical interface, something that I spent quite a bit of time on, I would put everything I could in group boxes, just because of the relative positioning and because it makes it so much easier to go back and make changes in the code to move things around on that Windows form, okay? And we have a group box at the bottom here, and there's, in this case, a label and a button. If I click the button, it just says hello world, okay? So let's take a look at the code. And like any other Windows Forms application, we need to add in the required C#.NET namespace and classes. So add type assembly name system.windows.forms and statically enable visual styles. Okay, so step 1. Step 2, we need to instantiate the form, and we've gone over that several times. Are you beginning to see a pattern? Step 3, building the form components. Well, first we need to build a group box, okay? So we build a group box and we size it and we position it accordingly. And then we build the other objects we want in our form. So a radio button and another radio button. There's our to be and our or not to be radio buttons, okay? Our text box. And then here's another group box that we build. All right, so we have group box bottom and group box top. Remember how I kind of, in my system, I changed the code so that I prefix it. So if I look at that variable, I know that's a group box because the first two letters are GB. That's just my system. You can come up with your own system. But, I know that's a radio button because it starts with RB. I know that, text box TB, group box GB, label L, and so forth. Okay, B button. So that's just my system. That's how I rename all my variables. Makes my coder, easier to maintain, easier to edit, easier to modify. All right, so we just build and instantiate all of these Windows form objects, labels, button. We are setting the location. We've already gone over that, setting the background color, setting the foreground color, in this case of our component. And then once we do that, down here, we're adding them to our group boxes. Okay, so GB top, the top group box, I add radio button 1 and radio button option 2. And I add the text box, the top output. Okay, and group box bottom, I add the label bottom output, and then I add the enter button. Okay, so again, if I run it, you see the form, right? You see the components? I'll drag this over here. So there's radio button option 1, there's radio button option 2, and here's our text box right here. And then if you look at the bottom, GB underscore bottom. So here is the label, right? Bottom output, that's right here, and the enter button. Okay. So once I've added my components, instead of adding them directly to the form, I add them to the group box. And then, after I've done that, then I add the group boxes to the form. Okay, so do you see how that works now? It's just one extra step, but I recommend putting everything you can inside of group boxes. It just makes it way more convenient and way easier to move things around. When you'll reach a point where you can't edit things with the GUI editor anymore. You have to start using code to edit your graphical user interfaces. It just always ends up that way. And if when you reach that point, you have put everything into group boxes, it'll be so much easier for you to manipulate things. But, notice how we set on some of these items. I don't know if I've gone over individual attributes, but remember you can always, in ICE, you can use a dot operator and autocomplete will pop up. So on the group box itself, notice we can give it a text value and height and width, okay, and the position under location. Uses a point object, so X coordinate, Y coordinate here. Notice on the radio button, it has a text component, auto size true. So that's based on the text value, how long that is, a width and a height, a location, X and Y, a font, and a point size, okay? Remember, you can always pause the video if you need to. That's a radio button or text box, same thing. Multi-line, remember that this value is false. So normally a text box is only one line. But if you want a big text box that can have multiple lines of text, you need to just change that value to be true. And then it becomes a multi-line text box. So a width and a height and an X and a Y for location and a font and a point size, okay? Here's our next group box, height, width, the text, the X and the Y coordinate where it starts at. Here's our label, okay? And I set this auto size to be false on the bottom label because if I didn't, it wouldn't show up unless there was text there. See where there's no text, I clear it, there's no text. If I didn't set this to be false, look, if I run the form, you wouldn't see this at all. This fuchsia color or magenta or whatever that color is, but you wouldn't see that at all until there was actually text in it, and then it would just be auto-sized to be just long enough to accommodate the text. And I didn't want that. I wanted to center the text and the label, and I wanted the label to exist whether there was text in it or not, because otherwise it would be dynamically changed and I wouldn't be able to position it in the center. See what I'm saying? So that's why I set this attribute to false in this example. And there's a text align option. And the way I got my text to center, middle center, it's just a constant, just a variable that I pass in that centers that text. A width and a height, an X and a Y point value, a font face and point size, and a hexadecimal color value. for the background color. Again, if I launch the form, see? So that hopefully explains those attributes. And my button, it just says enter. It's 120 wide by 42 high. I position it in my group box on my form at x130 y90, font calibre, and point size 15. And the fore color that's the hexadecimal value of white, okay? And the background color is the hexadecimal value of black. All right, that's just, I'm statically scoping in to these HTML color attributes, okay? So hopefully that makes sense. And that explains, radio button behavior. That's how you get radio buttons to allow only one radio button to be selected. So whenever you select one, it deselects all of the other ones. Just make sure you put them in the same group box. That's all you have to do. The only other thing is, remember we have to add event handlers. Remember that anything that you want to respond to a trigger with your Windows GUI forms, you have to add a pair of ears to it. Maybe that's a silly example, but maybe it'll serve as a mnemonic to kind of help you remember. So if you click on your component and it's not doing anything, it's not responding, odds are you probably forgot to add an event handler, or something's wrong with the function you're calling from that event handler. That kind of tells you where to look. So in this case, for anything that takes an action, that receives focus from the user, needs an event handler. So that means the first radio button, option 1, the second radio button, option 2, I need to listen for events. And if we hear that, right, we'll give them ears. And if we hear the event, the trigger, that they click, one of those radio buttons, then what? We're going to set the value of the text attribute of our text box, tb_top_output, to be if they click the first radio button. And if they click the second radio button, we're going to say or not to be. And remember, this escape sequence just adds a carriage return and line feed to put it on the next line, okay? And finally, our normal button with our label, we need to listen on that button too for a trigger if it gets clicked. And if that button gets clicked, we're going to take our label L bottom output.text and simply display hello world. And finally, we will always show our window with ShowDialog. That's how we'll do that form, right? And again, to be or not to be, and hello world. So those are all the event handlers listening for triggers for those components that I added to my Windows form. So we're going to look at a list box now. And we're doing the same thing, right? We add the required C#.NET namespace and classes. We build the form. There's nothing new going on here, so I'm not going to repeat it. The new thing is in step 3 when we are building our form components, and now we're using a list box, okay? And that looks like this, all right? So if you have a list box on this interface, here I have all these options in a list box, and the user or the player can select options in that list box, okay? And then you can code an event handler to respond to that. So how would we do that? We need to instantiate or build a ListBox class object first. So we instantiate, we build a ListBox class object. This text attribute doesn't really mean anything, it's just a label. That's not how you add items to a list box. We'll take a look at that in a moment. We set the width, we set the height, we set the location, the X and Y coordinate, okay? And we set the foreground color, the color of the text. And we set the background color, that's sort of that gray background color. And these are static data members from the ListBox class itself, okay? And here, it's a hexadecimal, HTML hexadecimal color value. All right, we create a font object. We set the font to be Comic Sans MS and the point size to be 16. And here's where we actually add items to the form. And the way we would do that, we use .items.add, and then we pass in as a string all the items that we want to add into that list box, okay? So here's the name of our MLP, 6 main characters. Twilight, Sparkle, Fluttershy, Rainbow Dash, Applejack, Pinkie Pie, and Rarity, okay? So this is a new component. We haven't used this one yet. We've already used text boxes. So there's nothing really new going on here, although let me again review, right? If you text boxes by default, the multi-line attribute is set to be false. So they'll only display text on one line. So if you want to display text on multiple lines, you just need to remember to set that value to be true, okay? In this case, yes, I want multiple lines of text, so I set that to be true. Everything else is the same. We've gone over. The only other new item potentially is this right here on the text box. I'm centering the text in the text box, and that works a little bit differently than it does from other components. So in this case, I'm scoping into the static member data and setting it to be center, right? When you see those double colons, remember, you're accessing something static. You're kind of scoping down into it and into an object that way. Okay, so all that being said, add the components to the form. To keep it simple, I didn't add this to a list box, but if you watched, previously, remember I said you would always add everything to I said list box, a group box. You would always add everything to a group box first, because it does make it easier to manipulate your code and move things around. So if this were if this were a larger, more complex graphical interface, I wouldn't just directly add a list box to the form. I would add it to a group box first, and then I'd add the group box to the form, like we did in the previous example. But to keep it simple, I'm just only adding these two components, and I'm directly adding them to the form itself. Okay, so here's our list box, here's our text box. Now, when something happens, when we do something to that list box, right? Remember what we said. You always have to code an event handler to listen to that event. Otherwise, it's deaf. It's not going to do anything. It's not going to respond to anything the user does if you don't code an event handler. And so in this case, on the list box itself, we added add click. So that's the trigger, right? It's listening for that event when the user clicks on that list box. And then if it hears that, if it detects that trigger, it's just going to go call the function do something. And what does the function do something do? It's going to simply get item text, and this is a quick and easy way. You can take the list box itself and get the selected item. Now that's just an array subscript value. It's just index 0, 1, 2, 3, 4, 5, and so on. But we don't really care about that. What we want the text value stored at that location, right? So a quick and easy way to do that, this is sort of common behavior when you use a list box and when you code its behavior, is get the selected item, right, the array index or subscript value, and pass all of that in as an argument itself to the GetItemText function, right? Member method of the list box object itself. So you're just nesting one inside the other. And that gives you a quick and efficient way to grab the text of the selected item. When I do, I assign it to this variable as a string, and then I just display it. In my text box, I'm going to say pony of the month is, add a carriage return and a line feed in that escape sequence, and pass in my string, right? So again, if we run it, all right, so our event handler it's listening, right? Our list box has a pair of ears. And now when I select these different items, that's the trigger. And when it hears the trigger, it goes and it calls do something. And when it calls do something, displays that item there. And who's blowing up my phone right now? Now we're going to take a look at a combo box, which is like one of those drop-down boxes that you access on a Windows form. So to add that to a Windows form, same basic process, right? You have to include the required C#.NET namespace and classes. You have to build the form. Step 3, you need to add the components. And we've gone over everything to do with text boxes so far, so I won't repeat that. The only new item here is the combo box itself, right? So we instantiate, we build a new combo box object with new object, and we're going to set the text on it. The initial text would be the final 5. The width and height we set. And then on a point object, the X and Y coordinate where we want it to appear on the form, the font, face, and point value. And notice that the syntax is similar to how we added items to a list box. So that, in a similar way, to add items to a combo box, I can add Gaius Baltar, Commander Adama, Starbuck Apollo, just using .items.add. And that'll populate my combo box with choices that the user can choose from their drop-down list, okay? And we need to add the components to the form, all right? So form main Controls.AddRange, and there's our combo box CB input and our text box TB output, okay? And remember, anytime that we do anything with a component or an object on a Windows form, it has to have an event handler. We have to give it a pair of ears so it can listen to a trigger. And then when it hears that trigger, then it can go do something. We can have our code jump to a function or go do something based on that event, that trigger. So in this case, we've been working with add-click as an event handler. We're going to use a new type of event handler called add_selected_index_changed. So when they click on that combo box, right, that drop-down list, and they select a new item, think of it like elements inside of an array. And think of each item that you select with the mouse, that's a subscript value, a different subscript value. So that triggers an event. That's you're changing the index value of an item every time you select an object from a list box or a combo box. So you can listen for that event too. Not just a click of the button, not just a click of the mouse, but you can listen for when an index has been changed. And there are dozens and dozens and dozens of different events that we can handle and that we can listen for. But this is a new one. So we listen for that, and when we hear that, right, that trigger, we go call the function do something. And what does that do? Well, okay, we are going to take our combo box, we're going to get the item text, doing the same thing we did with the list box, essentially, right? It's a quick and easy way to get the index value, so that our combo box CB input dot selected item, that would give us the subscript, the index value of the selected item in the drop-down list, and then we can get the text value of that element, right, of that particular position, subscript value in our combo box. We assign it to the string. We're going to add a carriage return line feed to our text box, and we're going to say the salon of the month is, add another line, and then display our message. And that would be the text up here, right? Gaius Baltar, Commander Adama, Starbuck, or Apollo. Okay? And then finally, we need to display our form, as always, we call ShowDialog. So what does this look like? If we launch it, right? So here's our initial value, right? The final 5. And if I pull down my drop-down list, watch, I'll select Gaius Baltar. Salon of the month is Gaius Baltar. I'll select Starbuck. Salon of the month is Starbuck. Commander Adama. Okay, so you see what I'm saying? So it listens for that event, the index value being changed on our combo box, and when it hears it, then it just goes and calls that function and changes the text of our text box. Let's take a look at picture boxes in this example. And it's just a quick and easy way to display an image object on your Windows form, okay? JPEGs or PNGs or whatever. Same basic process as for all our other components. We have to add the required namespace and classes. We have to build the form object itself. And then we have to build the form components. We've gone over button multiple times, so I won't repeat that, but here's the new item, PBView. And that's where we use new object and we instantiate or build a PictureBox object from the PictureBox class, okay? Set the width, set the height, set the X and Y coordinate where we want to draw it. And we have to we have to tell it where to find the file, okay? So I could fill this in with the absolute path, C:\, yada, 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 blah, blah, blah. But what I've done here, this is a quick and easy way. In parentheses, I've called split dash path and then parent and PS command path. That's a quick and easy way to get the directory that the script is being run from, okay? So in this case, I'm just telling PowerShell, whatever directory we run the script from, that's the directory where you're going to find a subdirectory called images and a file called alice.jpg, okay? And so then we use the image location attribute and we set it to be the value of that file, And you could do all this in one step if you wanted right here. I just split this into a separate step and I used a string to sort of make it more explicit. I wanted to chop it up into smaller pieces. Remember how to eat the elephant one piece at a time? Border style, in this case I wanted to wrap a border around it, but if I didn't, I could set that attribute to be 0 instead, okay? And then the size mode. Now, I do have one event handler down here, right? Add click, but it's for the button, not the picture box. The picture box doesn't need to listen for any behavior. I could listen for someone clicking their mouse in the picture box if I wanted to, but that's not how I chose to create this form. Instead, I'm only listening for events that happen to the button, my bViewButton object. And if somebody clicks on it, then I'm going to go call the function revealTheView. And in revealTheView, I'm just going to change my file. It was Alice. Now it will become wolf.jpg. So I changed the string value and then I set that, the image location attribute on my PictureBox object to be the new file. Okay? And it'll automatically repaint and display my new image. Okay? And don't forget, we've got to add our components to our form. Very simple form here too, only 2 components, right? So to my form, I'm adding the PictureBox object, PBView, and the button. And it's going to listen for our event. The button will listen for a click event. If it hears a click event, it'll change the image. So let's launch it and see what happens. Okay? So it starts out, and here's a picture of Alice. I can't explain myself, I'm afraid, because I'm not myself, you see. Curious and curious, said Alice. All right, so it's a bit of all right. So anyway, she's a bit of all right. She's like, I'm sorry, I'm stuck talking in a bit of an English, a little bit of a British accent here, but it's not very good, I know. But it's okay. Anyway, so we click View, and now it displays our wolf. Yay, sound effects. So that's our PictureBox component. Now we're going to take a look at checkbox buttons. They're sort of like radio buttons, except radio buttons have a different behavior. If you put radio buttons in the same group box, you can only select one at a time. For any radio button in that group box, if you select it, it will automatically deselect all the other radio buttons. But that's not the case with checkbox buttons, okay? With a checkbox, you can have multiple selections. It's up to you. It depends on your interface needs and what you're doing with that particular GUI form and how it interacts with your script, your program. But, okay, so for this component, look, there's nothing new here. Have to include the required namespace and classes. We have to build the form, step 2. Step 3, we have to build our components. This time we're using GroupBoxes, okay? So we have a GroupBox top, and we are going to, here we're going to build some check boxes, all right? And this is very similar to other components, other attributes. It has a text attribute, right? We have to build it using new object, and we have to instantiate a checkbox. We can set the text to James T. Kirk. Auto size is false because I want it to be a fixed size. I don't want it to auto size in this case because I want to position them around my group box accordingly. A set width, a set height, and an X and a Y coordinate where we want to draw this checkbox inside of our group box. We'll add it later. Okay, so that's check B Kirk, and we have 3 more checkboxes. All right, so we're adding 4 checkboxes total, and we have a text box for output, a multi-line text box for drawing our output. Okay, so we need to add those components to our form. So remember, with a group box, we add the components to the group box first, right? So I'm adding my 4 checkboxes to the group box, okay? And then when I've done that, then I can add the group box itself to my form here, as well as the text box, right? The text box, the main output text box is outside our group box. Now, I added 4 event handlers, okay? 1 add click for each checkbox. And so if that item is clicked, what's going to happen? It's just going to set the text of the text box to be the value of the selected checkbox that's in the group box, okay? And here we're calling ShowDialog to display our form. So if we run it, let's look what happens. GB best starship captains of all time, James T. Kirk. Okay? And then I could choose Benjamin Sisko, Jean-Luc Picard, Catherine Janeway. All right? Now, this behavior, okay, there's nothing syntactically wrong with this form, okay? But notice I have all 4 checkboxes selected. Now, if these were radio buttons, it wouldn't be a problem because as soon as I selected one, it would deselect all the others. But in this case, that's, these aren't radio buttons. These are checkboxes. And because they're checkboxes, I can select multiple values. I can select all 4 if I want, but when I do, notice that the best captain is still Benjamin L. Sisko. There's no, it's not, the logic isn't working the way that it should, okay? So let's take a look at another example, and instead of using the add click event handler, let's look at how we would handle these checkboxes in a different way. All right, and I'm going to scroll down here, and if you look, we're doing something different here. So in this form, this time we added a button, okay? We listen for a click value, and when we do, we're going to use the Boolean checked attribute, and that just returns true if a checkbox is checked. And we're going to have if, no else if, no else, but just 4 if statements. So this will change the behavior of our form so that if they have multiple checkboxes selected, it'll concatenate or accumulate and add those multiple values to the checkbox. And we're just using the overloaded addition assignment operator here, right? So we're using the same components. The only thing we've done differently is we've added a button here. And instead of listening for clicks on the checkboxes, we're listening for a click on the button. And the button says, who is your captain? And based on that, it will go call this function, and this function will look at the state of checked on those 4 checkboxes. And if it returns to be true, it will append that or add that in to the text on our text box. And so potentially, if all 4 checkboxes are checked, all 4 captains will appear. So you can see how this behavior is different, right? If I choose one captain, just one captain. And if I deselect them and I choose another one, all right? But if I choose all 4 captains, watch. And then it selects all 4 items. So I'm just showing you there's multiple ways that you can handle events and multiple things you can listen for. You have to decide what's the best for your interface, for your form, and what kind of behavior you want to happen. What kind of triggers that you need to get other code to happen on the back end in your algorithm or in your script or in your programs and so forth. Now we're going to take a look at a progress bar, and this is kind of a fun component among Windows Forms objects. The same basic process for building a Windows form. Add the required namespace and classes, build the form object itself, and then we need to add the components to the form, right? The only new item in this instance is ProgressBar. So we're going to build or instantiate using new object, a new ProgressBar class object. And we'll set the width, we'll set the height, we'll set the X, and we'll set the Y coordinates, okay? And we're going to create some radio buttons, and we're going to add them all to a group box. And remember what that does. When you add whatever radio buttons we add into the same group box, it only allows you to select one radio button at a time, which is good. We don't want to be able to simultaneously set the power level at 25% and 75%. That doesn't make sense. It has to. In this interface situation, in this particular graphical interface, it only makes sense to allow the user to set one option at a time. So that's a perfect example of why you'd want to use a radio button inside of a group box, or a group of radio buttons inside of a group box, so that only one can be selected at a time. Remember what we said with event-based programming and with a graphical interface, you have to more carefully control what you let the user do, because they can move in any random order and do things that they shouldn't do. In reality, it doesn't make sense to set something at 100% power and at 50% power. It can only be one or the other. But that doesn't mean that you can't create a bad interface that lets your user do that. And then therefore that confuses your program and confuses your code. So you have to kind of put some thought into your interface and what you let the user do and how you control their input, so they don't end up doing things that they shouldn't do. So we add these 4 radio buttons, right? 25, 50, 75, and 100% power. We're going to add them to this group box, and we're going to use them to manipulate this progress bar up here, okay? So next thing, right, we have to add our radio buttons into our group box. So group GB amount, we're going to add radio buttons 1, 2, 3, 4, 25, 50, 75, and 100%. Then we have to add our group box to our form, as well as the title and the progress bar itself, okay? Now, what's the event handler? We're going to add an add click event handler for each radio button. And if they click on that radio button, that event is triggered. We listen for it, right? We add ears to each radio button. And if they hear their name called, they'll respond to that trigger. And when they do, it's just going to set the value attribute of our progress bar to be 25, 50, 75, or 100. Progress bars are very useful components. You can use them to show, progress of processing a certain operation, or loading something. I mean, there's so many different things you could do with the progress bar, and plus they just look cool. And finally, remember, we always display our Windows form by calling ShowDialog, the ShowDialog method. So I'm going to run the form. Here's our empty progress bar, and look, 25%, 50%, 75%, 100%. Okay, does that make sense? You see what's going on? You see in the event handler code, each of those radio buttons is listening. So again, if I check 25%, or 75%, or 50%, or 100%, and then the progress bar would respond accordingly because its value is being set each time a click event is triggered and that radio button hears its name being called. Now we're going to take a look at a different kind of text box. Okay, this is a masked text box. Same basic process. Add the required namespace and classes, build the form, and we're going to add components to the form. Okay, but this time, the only new component here, we've gone over all the others, but the only new component is this item right here, a masked text box. It allows us to set a mask attribute and therefore control the input. So we can use regular expressions, we could match it to a date type pattern, we could match it to a numerical pattern, you name it. But that's all controlled with this attribute right here, the mask attribute. All the other attributes are the same. These would be accessible and available through any normal text box object, including a few that we haven't gone over yet. For instance, if I want to convert the characters in a normal text box or a masked text box into, make that a password field so it hides what the user's typing in. Typically you see that behavior when you enter a password, because we don't want anybody looking over our shoulder to see the password we're typing in. Well, you do that by setting the password char attribute. It's normally null, but if you set it to be any value, then this is the character that will appear in that box when they type. And so that way, if someone were looking over their shoulder, they still wouldn't see them type their password, okay? Tab stop and tab index as well, because here we're saying we want tab, when we launch the Windows form, we want that object to receive focus for input. So that's why we're setting the tab stop. And then we want to select the text, and this just makes it easier, because if we select it, all they have to do is start typing, and it'll erase whatever's in that text box and replace it with what the end user is typing. You see what I'm saying? So to do that, we would just set the selection start attribute to 0, the first character, and then we would want to go from that first character to the very end of the text. And you can quickly get that via text.length. Works kind of like array.count, or with a string, the string.length method, okay? So this is the only new items. Now, this is the most important one, our mask value. So we are telling our masked text box that we only want to accept numerical input. We will not accept characters, okay? And everything else is the same. The button, the event listener is the same. We're not doing anything. If they click the button, we're just going to display that. We're just going to take what, our text here, and we're going to display it in our text box. Whatever they've typed into our masked text box will display in our normal text box. We'll demask it, so to speak, and ShowDialog to show that window or that form. So let's see how this works, right? This mask attribute. So we'll run it, and if we run it, I'm going to type a character. I'm going to type in WERTYUIOP. Nothing happens, see? Because it's not a number. It doesn't have a numerical value. Now, what if I type a number? 444. Yes. So it allows me to input that data in that text box because it's of a numerical format. And you can use that mask attribute to do all kinds of things. Like you can match it against regular expressions, dates, numbers, you name it. Different combinations and things that you want to, it's your way of enforcing a standard of input when you ask the user for a certain kind of input, okay? And notice here's the password character. And that's because we set this option here, password char right here, we set that option, okay? And if I click on the button, event handler, it just displays the number that I typed. So I'm masking and then I demask, okay? And I'm hiding, taking in password information and hiding it with the asterisk character. And here I'm not hiding it in this normal text box. Does that make sense? Okay. So 2 items. And again, you can use this with a normal text box if you want to. Attribute pass character, but the mask attribute is only available if you instantiate or build a special kind of text box. And that's a masked text box object. Now we're going to take a look at adding menus to a form. And that can be a very useful way to add controls to a form that don't take up a lot of space. And in other words, so look, I click on About, All About Me, Help Me, View, Changing the View, Options, and then we can add submenus. So File, Open, Save File, and Exit. All right, so we can add menus and submenus to any Windows form. And the syntax, it's very similar to other components. Let's take a look at the code. So to do this, just like with any other Windows form, you need to basically import the namespace and classes. Second step, you need to build the form itself, okay? Instantiate it. Third step, you need to go ahead and create and instantiate the form components. So in this case, the first thing I'm going to do, main menu, that's sort of the main strip at the top of my form. I'm going to instantiate with new object or build a menu strip class object. Once I do that, then I can build 2 tool strip menu items. Boy, I have tongue twisted there. I can instantiate or build tool strip menu items, okay? And there's 2 ways to do this. You could just construct it the default way, and then you could set, there's a .text attribute you could set on a tool strip menu item, but why not, instead of 2 lines of code, why not just do it in 1 line of code? In which case you can pass a string argument into the constructor, and it'll do the same thing. So in this case, we do that here, and these are going to be our menu items. There's our parent menu, and here's our submenu. They are all tool strip menu items, okay? And our main menu is a menu strip. So we could have multiple menu categories on a Windows form, I guess. You could have multiple main menus, if that's syntactically correct to say. But in this case, we have 1 menu, 1 main menu, 1 strip right across the top, and then these would all be choices, menu items that we will add. So when I plan out my menu, as I code it, once I've built my main menu, right, my instance of menu strip, then every menu choice simply becomes an instance of tool strip menu item. So File, Open, Save, Exit, okay? And all these done here too, tool strip menu items, right? Options, View, Help, About, okay? Now these options here, I named them submenus because they're all going to go under my file menu. But it's not because I named them submenus, that's just arbitrary. I just did that for me, for my sake. So when I glance at my code, I'll realize, that's not a parent menu choice. That's a submenu item that will appear underneath a parent menu choice when they click on it, okay? That's arbitrary. You could call that supercalifragilistic or rainbow tutti frutti unicorn if you want to. It doesn't matter. But you do what works for you, okay? What's important is the order in which you add them using Items.Add. And we'll take a look at that in a moment, okay? So again, we need at least one menu strip, and then for each choice, whether it's a parent or a child, a submenu item, they're still all instances of the same class, tool strip menu item, okay? And you can name them accordingly if you want to. So how do you differentiate between a parent menu versus a child menu item? The order in which you add them. So look down here, right? Under stage 4, where I've kind of designated that with a comment tag. Okay, so here, I'm going to take menu file, okay, tool strip menu item, and I'm going to add DropDownItems.Add. I'm going to add open, save, and exit. They're all the same type of object. They're all tool strip menu items. But notice that the method that I call, right, it's on menu file itself, and I call DropDownItems.Add, and I pass in the submenu items open, save, and exit. So that's how I get these items to appear beneath or underneath my file menu item. Here's my parent object, right? The file menu. But instead of calling Items.Add, I call DropDownItems.Add. It's a different method. And that's how I add my submenu items. Now the rest of these, they're all at the parent level, right? And I just add them to my main menu object, that main strip of what we built up here, main menu, our instance of menu strip, right? So menu file, options, view, help, and about, okay? And when I'm all done, I just need to add the components to my form. And I only have to worry about adding the main menu strip item, right? So here, main menu, it's my main menu strip item. And I added all of my tool strip menu items, both the parent menus and the submenus to main menu. So when I get down here to step 4 and I have to add components to my form, I only have to worry about adding the main menu item. And it adds all of the child objects associated with it, okay? And then my form, TB output. Man, my phone is blowing up today. And then I just need to code event handlers. A menu item is just like any other component, on your form. Just like a button, just like a checkbox, just like a radio button, any other component, a ListBox. You have to listen for events, triggers. When you hear them and they're detected, then you execute code based on that trigger, based on that event. So our event handlers for each one, each menu item is going to be add click, and when they click on that menu item, we're just going to do something simple. We're going to display text in that text box. And here we show our form. And again, if I run it again, you can see the behavior. Parent menu item, it just displays text all about me. Help, help me. View, changing view. Options, options. And then here's the parent menu item, and look at the child menu items that we added with our drop-down items. So open displays open file, save displays save file, and exit exits the program. Okay, so drop-down items to add a child menu object, and Items.Add to add a parent menu object. And yet, they're all instances of the same class. It just depends on the method that you use to add them and what you add them to. Now we're going to take a look at panel object components. So again, same basic process, add your required namespace and classes, build yourself a form, and then create your components. Only this time we're instantiating panel objects with new object, right? So we have panel 1, we have panel 2. We'll create some objects, checkboxes, radio buttons, buttons, and so forth, and we're going to add them to our panels. Well, the syntax for this It's just like adding things to a group box, right? So I'd add components, a combo box and a text box to a panel 1, and I'd add components to panel 2, checkbox 1 and 2, radio button 1, 2, button 1, text box 1. And then after I've added the components to my panels, I then add my panels to the form, okay? And display the form with ShowDialog. It's always the case. So, pretty much identical to the way group boxes work, but these, in this instance, are panels. And the last item we'll cover, what if you want to play like a sound with your form, or like, make a sound effect when they click on a button or something. You could have a little beep beep sound or something when they click on a button. Some people like to do that. Well, an easy way to implement sound and playing a sound in your Windows form GUI interfaces and programs is to use a sound player object, okay? And so again, I would just instantiate or build a system.media.soundPlayer object. I need to tell it where my file is. Remember, this tells it to look in the same directory that I'm running the script from. And I have a subdirectory called sounds, and I have wolfhowl.wave. Okay, in this case, I'm playing a wave file. And then I use the play method on my sound player object. So if I do that, in this case, when this function gets called, right, then it's just, it's going to play the wolf sound, okay? And then also here, right before I call ShowDialog, before I display my GUI, my form, here I'm going to call thunder1.wave, and it'll play a thunder sound effect. And this is just, if you look at this form, this is just using all the components that we've gone over for our Windows forms. So look, if I launch it, okay, and then here's list boxes and buttons and radio buttons and so forth. And then if I click go, and here's our picture box, right? Our picture box item. So again, if I run that, right? So you hear the initial sound effect when the form loads, and then if I click go, and it's changing our picture, but you hear that's a sound player object. So a very easy way to use sound in your forms. 3 lines of code. And we'll look at one more interface that uses the same thing. So this is for a blackjack game I've been working on, but we're doing the same thing here, right? Begin the game, and I instantiate a sound player object. I'm going to go find the path in the directory the script is running in, the subdirectory sounds, and I'm going to call the play method to play my sound player object. So here's
welcome to Casino Angelique.
Okay, and just welcome to Casino Angelique, and it just plays a little shuffling sound. So a quick, easy way to implement wave sounds in your Windows form apps. And there are other ways and other libraries we'll go over in the future. This is probably the easiest and the quickest way with just 3 lines of code built right into System Media Sound Player. Now, you can use each of these examples as templates, and you can build your Windows forms with code, and to a certain extent, you will have to do that anyway. You can use GUI tools also, but they only go so far, and at some point, you do have to start, coding your interface out. But there are tools out there to help you get started, at least to maybe graphically, lay things out. And the one that I like, because it's free, is this one, poshgui.com in the editor. So here, if we run this, it's a free tool. And kudos, let's give credit where credit is due. So kudos, this guy here, I probably would not pronounce his name right, and I apologize because I'm just stupid. But Maciej Obuchowski, is that how I say it? Anyway, this wonderful, kind-hearted, brilliant human being has provided this tool for us to use, and you can buy him a coffee if you'd like. And he did, I don't know him personally, but a brilliant man designed a brilliant tool here. So the developer, and this is just a graphical WinForm design tool. All right, so look at this. You can drag a group box onto a form, and And then in that group box, I could add checkbox. And I could add a radio button. And I could add, a progress bar if I want to. Or I'm just adding, a picture box and just adding different items to a form. Add a label, okay? If I do that, it doesn't go over menus. You're going to have to do menus and sound and stuff like that in code. But notice that it writes the code for me. And so then what I can do is I can copy and I can paste all this into ICE or into an IDE. And then I can go in and edit the code. And I've still noticed that sometimes the positioning is different. So you may have to edit the X and Y coordinates. You may have to edit the width and the height. You may want to rename your variables to something more meaningful. But it's a nice way to get started, right? Because it gives you a graphical way to position things on a form. Because otherwise, if you start out coding, and you'll still have to do this a lot, but you won't have to do it as much if you use a GUI design tool. But ultimately, then it's a lot of you change the code, you reload it, you change the code, you reload it, you change the code, you reload it like 1,000 times until you get the components right where you want them. And to precisely get them where you want them, you will have to still do some of that. But this can save you a lot of time just using a GUI design tool like this. And there are other options. In this case, Visual Studio Code. And this is a free IDE tool. And there are things to do PowerShell. There are plugins that you can use, modules, to code in PowerShell. And specifically, there is one that you can buy that a developer charges for, Iron Man software. It's $100, and it's PowerShell Pro Tools, and they have a GUI PowerShell form designer. Okay, and probably the fanciest and most amazing and coolest thing out there for PowerShell development is PowerShell Studio. And PowerShell Studio 2020, that's by Sapien, and it was like $399, so $400. It's pretty pricey. But if you have the bucks to spare, and I'm thinking about getting this eventually because it could be a big time saver for me. Right now, I'm still just using ICE and free tools and things, but this offers a lot of cool features and a lot of functionality. And they too have a graphical GUI Windows form designer that you can use for your PowerShell projects. And there's another way too that I haven't gone over, but you can use Visual Studio and use the C# form design app. And there's a way to you can include the XML file and do GUIs that way. So these are just some graphical options to help you as you design. You can use Notepad, by golly, if you want to. You can do it all in code. And sometimes you have to because that's all you have. But be aware, there are power tools out there that can help you, that can save you time. And these are just some of them.